You know that weird, invisible pull you feel between two magnets? It's probably one of the first bits of science magic we ever experience. But how do you go from just feeling that force to actually truly understanding it? Well, today we're going to look at the amazing tools that are making the hidden world of magnetism totally visible for a new generation.
I mean, it really boils down to this one simple question, doesn't it? How on earth do you get a handle on something when the main event, the thing you're supposed to be studying, is completely invisible? Seriously, think about that. It's a huge hurdle for anyone trying to learn physics.
And that right there is the core of the problem. You just can't see a magnetic field. You can only see what it does. And that's exactly why so many students have a hard time really building an intuition for how magnetism works. You're told to imagine these invisible lines of force, but man, that is a big abstract leap to make. So how do we close that gap?
Well, this is where technology steps in. A magnetism simulation is basically a virtual laboratory. It's a tool that's built to take those invisible forces and bring them to life, right there on your screen. It's all about making the abstract, well, concrete and interactive.
But you know, these simulations do way more than just let us see things. They're actually changing the whole game when it comes to science education, because they solve some really old, really practical problems.
When you put the old way and the new way side by side, the difference is just stark. Physical labs, they cost a fortune, they've got real safety risks, and so much time gets wasted just setting up and cleaning up. Virtual labs completely flip that around. They're cheap, they're totally safe, and you can get started instantly. And that's not just about convenience, it's a real game changer for schools. It lets them offer a much richer science experience without the massive budget.
Okay, so we know why they're so useful, but what's it actually like to use one? How do you go from just clicking a mouse to really understanding a tough physics concept? Let's just walk through an example.
All right, so picture this. You're using the magnetic field of a circular loop simulation. First, you tweak the current, maybe you set it to 1 amp. Then you just drag this virtual magnetic probe to the center of the coil. The teslameter gives you a reading, and you click to record it. Easy. Then you move the probe a little bit, say 1 centimeter away, and record the new number. You do this a few more times, and then, and this is the best part, when you're done, all your data just automatically downloads to an Excel sheet, all ready for you to analyze. No mess, no fuss, just pure, clean data.
And all that clicking and dragging, it isn't just for kicks. Every single action you take is tied directly to a real learning outcome. It turns that abstract theory into something you can actually experience.
So what's the end goal here? It's about letting students see and understand those squiggly magnetic field lines for themselves. It's about letting them play around with the relationship between magnets and currents to see what makes a field stronger or weaker. They're not just memorizing facts from a textbook, they're actually building a solid mental model. And they're learning the real skills of science, how to gather data, how to analyze it, and how to figure out what it all means. And you know, this whole approach isn't just a one-trick pony. The possibilities here are really broad. Students can dive into the magnetic field of a current loop, or they can investigate the invisible push on a wire with electricity running through it, or even figure out the pole strength of a regular old bar magnet. Each simulation is like its own self-contained lesson, a deep dive into a key part of magnetism.
I really love this quote because it just hits the nail on the head. This isn't about passively watching a demonstration. It's about active learning. Students are the ones in the driver's seat. They're changing things, seeing what happens right away, and really thinking about what it all means. They are doing science, not just hearing about it.
And this big shift from passive to active learning, it's not just some small tweak. It really points to a much, much bigger transformation in how we teach and learn science, making it more accessible, more engaging, and, just plain more effective for everybody.
So, that leaves us with one final thought to chew on. We started this whole thing talking about the invisible force of magnetism, and we found a way to actually see it. It kind of makes you wonder, what else is out there, just waiting to be made visible? From the bizarre world of quantum mechanics to the complicated dance of molecules in our bodies, what's the next invisible concept that a simulation could unlock for us? It's a pretty exciting future to think about. Thanks for tuning in.